All right. Well, hello, Fruitport High School. Welcome to another lesson. We're going to be doing a unit to end the school year on acids and bases. And this is a fun unit to end with because it's so much acid and bases stuff in your life that you can maybe relate to. Sometimes then we can do some labs. We'll do a couple virtual labs and demonstrations instead. If you have done things in the correct order as posted in Google Classroom, you should have seen from me a warm-up video where I did a little demo, my favorite one called the magic pitcher. And it's not magic, it's based on acids and bases. And we'll see if we can get to some understanding on that coming up. So another thing that you might have discovered is that we'll talk about properties of acids and bases. We'll also talk about the pH. That's a measurement of acidity and basicity. And yeah, we'll look for different things that come up. So this week 7, we're going to learn about this stuff. So not everything is acidic or basic. There's things that acid and base is really not part of things. Sometimes because students will be like, what's the pH of my hair or something strange? And sometimes that's not a necessarily appropriate question. Also, people think acids and bases are opposites of each other, and they do have a lot of opposites, but there's some things that they have in common. So look for what's different between them and look for what's similar between them. There'll be a quiz eventually. And yeah, you experience these every day in life. Here's a few examples. In cooking, we use acids all the time to help with taste. You'll see people squirt lemon and things like that. If you watch cooking shows, always talk about needs more acid or something. Lawn care, I'll put limestone down on my lawn once every couple of years to change the pH of the soil a little bit. Gardeners know about pH of soils. Farmers are really informed on that stuff. The environment is a key factor for health. And so if you went on the middle school field trip where you went on a Grand Valley research boat, you may have tested the pH or the buffering ability or alkalinity. That all relates to pH stuff. The body systems, the pH of your blood is very different than the pH of your digestive system. Your stomach has a really extreme pH. That's why, if you were to vomit, you might feel this burning as it comes up your esophagus and your throat. There's some pH stuff going on there that you're not used to dealing with. Cleaning supplies, of course, are filled with extreme pHs too. So you'll see reference to those throughout our week. All right, so here we have properties that I want to compare, looking for different properties of the pH. You may have seen this classic pH scale. They always have 7 in the middle because 7 is neutral. And acids is any pH that has a value less than 7, and bases have a pH value greater than 7. Now, if we were in class, I wouldn't have put that fact out there, and I'd ask, what do you know about the pH scale? And 7 usually comes up, and I said, well, what's the pH of acids? And someone will yell out 1 to 6, 1 to 6, and I'll say, okay, all right. Someone else will yell out, no, 0 to 6, and so we debate if the pH scale where it starts, and then 6 is the common number. And I'll ask this question: what if you're right here? What if you're 6.4? What if you're 6.4? Are you acidic or are you neutral? And the correct answer is that you're actually slightly acidic. 7 is neutral, but 6.5 would be acid. Now, if something's 6.5, it's so close to neutral, we kind of think about it as neutral. So keep that in mind, that any number less than 7, and here's the new stuff. This arrow means you can go past 0. You can actually have pHs on the acid side into the negatives. And pHs are often thinking of ending at 14, but you can actually have a pH greater than 14. I have some acids in our chemical storage closet that have negative pHs. Okay. Well, that's one big difference is pH. The definition, here's more of a definition. Acids are strongly associated with hydrogen positive 1 ions, H plus ions, and bases are associated with OH negative 1 ions. If you remember from earlier this year, OH negative 1 is called hydroxide. It's a polyatomic ion. Now, there's other definitions of acids and bases that are more thorough, but this is a great introductory first year chemistry definition that you don't need to know the other ones for this at this point. Now, you might notice that if you took an H from an acid and an OH from a base and put it together, you'd have two H's and an O. H2O, water, and we have this neutral. And that relates a little bit to the demo from our warm-up today. Okay. Here's some examples. This is a very famous acid called hydrochloric acid, HCl, and this is sulfuric acid, H2SO4. And you'll notice that in this compound, the hydrogen is listed first, and same with this one. That's so it really pops out in the eye. If you see a compound written down with hydrogen first, boom, you can think immediately acid, H. And here you have sodium hydroxide and a chemical called potassium hydroxide. And in here is the OH with the negative charge is part of that. The OH, the negative is not listed, but it's in there. And those are examples of bases. So I have two more examples for you that are a little bit different. This is acetic acid, or the active ingredient in vinegar, and you have HC2H3O2. Now, you might be wondering, why is there a lone single H here and three more H's here? Wouldn't it be like better to just say H4? Well, we don't do that for two reasons. One is we have a polyatomic ion, C2H3O2 is a polyatomic ion called acetate, and we like to keep polyatomic ions grouped together. And we also want to put a hydrogen in front because it pops out as acid. Okay, see that H in front, you immediately can think acid. Now, this is a famous base you have probably in your home called ammonia. And ammonia does not have an OH, but it is a base. And it shows up on the, greater than 7 on the pH scale. And notice we put the hydrogen as the second element listed, so it doesn't pop out as hydrogen in front, acid. This is a hydrogen at the end because it's kind of almost a trick. But it's an exception to kind of the pattern that we learn in 10th grade, but it's really important to know that. Example, it's very famous. Okay. Some other properties is acids have a sour taste while bases have a bitter taste. Now, you should never test any chemicals in our class. And this is sour and bitter are hard to define, but examples. So you think of like grapefruits or any citrus foods, those are a nice sour. I know some kids thinking Sour Patch Kids taste sour. Yes, we know that, right? Bases would be like coffee has a bit of a bitter taste. Soap, have you ever had your mouth washed off with soap when you were a little kid? I had that experience. That tastes bitter. And so maybe like a banana peel or an orange peel, those are a bitter taste. Or chocolate, baking chocolate that's unsweetened, that has a bitter taste too. All right. Another famous property of acids is many acids react with metals. When they do this, they actually produce hydrogen gas, which is flammable. Now, I have to remember this because there's some old pipes in our school that are still made of metal. And if I were to pour an acid down the drain, the acid could react with the metal pipe. So I make sure I flush it with lots and lots of water, like an hour's worth of water to dilute the acid so it doesn't react with the metal pipes in our school. And a fun is bases are famous for being extra slippery. So, like water's slippery, but like soapy water's a little bit more slippery. Bases are slippery. Sometimes I'll get a base on my fingertips in the lab by accident, and I immediately know that my fingers feel extra slippery. So here are some properties that help get us an introduction comparing acids and bases. Now, here's something that we have both in common. So acids have a lot of misconceptions. People think like in a cartoon world, if you were to spill some acid, it would burn a hole through the table and burn a hole through the floor. And that's not the case. But acids on one extreme and bases on the other extreme can both be harmful properties. Like if you were to spill an acid way over here on the pH scale and a base way over here, they both irritate your skin and hurt and turn red. And so they both can be harmful properties, but the the other parts of the compounds, the specific compounds have specific properties. And also acids and bases can both conduct electricity. Water can conduct electricity, but pure water is not great at it. But if you have things dissolved in the water, things that become acid or things that become base, they can conduct electricity. Okay. Let's talk a little bit more about pH. All right, I'm going to try to move this screen down here so you can see the words. Okay, so pH is actually a math formula, and this is how pH is calculated. You actually take the negative logarithm of a bracket H plus. Now this bracket H plus means concentration. We learned about that earlier this year. That's about how much solute is dissolved in a solvent. And we're going to use the word molarity to talk about concentration. You might hear the word molar, and you might see a big giant capital M. So even bases have a little bit of H plus. And so when we find the pH, you take the negative log. Now, in math class, you may have learned about logarithms yet. You have a log button on your calculator, and this is a scale that's based on the power of 10. And when you learned about logarithmic scales or logarithms, your teacher in math may have said, like, well, you're going to use this in science class, and the pH scale is what they might have been talking about. The other famous scale that is a log-based scale is the Richter scale, which measures earthquakes. And you might think an earthquake of 8 is twice as big as an earthquake of 4, but that would be if it was a linear scale. But because it's a logarithmic scale, a earthquake with a power of 8 is actually 10,000 times more powerful than an earthquake has a power of 4. Okay? Now, if this is confusing, if you ever had to do a homework problem, you literally just hit the negative button on your calculator, you hit the logarithm button on your calculator, and then you hit the molarity that will be given to you. It's pretty straightforward. We can practice it on your calculator. Try this. Try if you can take the pH of an acid called hydrochloric acid with the molarity of 0.01. If you want to try on your calculator, hit negative, hit log, and hit 0.01, hit the equal buttons, and see if you get the answer of 2. Now, some calculators might require some parentheses. Some might require the negative being hit last, depending on how fancy. But most scientific calculators, you just hit negative log 0.01, and you get the answer. Okay. Now, to prove it's a logarithmic scale, we can go on. I'm going to change this 0.01 to a different number, to just 0.1. And if you were to hit negative log of 0.1 in your calculator, you would get an answer of 1. Notice I changed the concentration by a factor of 10, but the pH scale measurement only changed by 1 digit. If we keep going, what if I had 1 molar hydrochloric acid? That's the next slide. That is 10 times more powerful, acidic, and we have an answer of pH equals 0. Negative log of 1 equals 0. And actually, this is one of the strongest acids I am allowed to order. It's 12 molar hydrochloric acid. And if you take the negative log of the number 12, you get an answer of negative 1.1, which is trying to prove to you that the pH can go past 0. It's just a math formula. Okay. Now, really quickly, let me take a little side note, is that sometimes we'll use the word strong and weak acid incorrectly. And people will think way away from neutral is a strong acid. And if you had a pH that's like 4, 5, or 6, that's a weak acid. And that is not the exact definition of strong and weak acid. The technical terms we should use is 5 and 6 would be low acid. Around 3 would be middle acid or medium acid. And way up here at 0 and 1, that would be a high acid. If you see the word strong and weak, that's just, most people kind of use that, but it's not technically correct. So, side note for you. Okay, again, this is a logarithmic scale, so let me just kind of try to, each number is a factor of 10. That means multiply of 10. So 5 is definitely more acidic than 6, right? pH of 5 to pH of 6. But it's one number, so 5 is 10 times more acidic. Okay. Now let's compare pH of 4 and pH of 6. If I were with pH of 6 here, pH of 4 here, you might think, well, if 5 to 6 is a factor of 10, then 4 to 6 would be a factor of 20. But actually, it's a factor of 100. A pH of 4 is 100 times more acidic than a pH of 6. That's because it's a logarithmic scale. Okay. All right. Now, to finish the lesson, there's some videos, and I'll put the links in Google Classroom, or you can open them up here. Now, you should have watched this one already. If you didn't, please go back and watch video 1, my introduction to acids and bases, the magic picture. Then I want you to watch video number 2. This is a fun video with my favorite comedians / magicians that, jokingly make fun of some hidden, secret rules of magic. Then I will explain the demonstration again with video number 3, where I break the same rules of magic. I also have a 4th video if you wanted to learn a little bit more. Okay. Now, your homework is going to be an online lab simulation. I'll show you how to get it, but you'll Google FET pH, and we'll look at it a little bit together before I close things up, and you'll get a homework copy in Google Classroom. And you might want to, for the quiz, open note quiz next week, you might want to make a Venn diagram comparing acids and bases. And so you guys know what that is. You can use our lesson right now. So let me exit out of this Google slideshow for you. Please don't judge me for all my tabs. And let me show you what the homework will look like. All right. So you'll get a homework where a copy of a Google Doc where you can fill in all these little squares in a table. And one of the things I want you to do is I want you to predict the pH of all these chemicals before we even start. And then we're going to do a virtual test. Now, to do this test, you need to open up a new tab. And, oh man, I'm looking at my picture. I want to be professional today. I put on a little collared shirt. I'm wearing shorts that require a belt. And let me tell you, I don't think I've worn a collared shirt or a belt in a couple months. I've been dressing much more comfortably since being at home. So, but I wanted to, be professional today. So, here we go. So you can just Google PHET-pH. Mine auto filled in because I've used it before. And if you Google FET pH, you will come across a link, and there it is, pH scale, dilutions and concentrations. And I've also sent the link directly here in there, but if you don't use the link, you'll get to this slide. And we can just click on this little play button. If you do this on your Chromebooks, it'll work out just fine. And we'll open this up. It's a little bit slow right here. And I'm just going to show you me playing around with the simulation so you can then do this. It took me a few minutes to figure out some of the subtle points of this. There's 3 options, but we're going to deal with the macro option. And what we have here is we have a pH scale. And what we can do is we can put in soda pop, or we can change it. We can put in hand soap, and it kind of refreshes with hand soap, right? And the pH is not reading because we have to actually click and drag this meter into the hand soap. If it's too high, it won't measure the pH. So we have this here, and you can see the pH is now listing it as a certain number. And now we have 2 buttons we can click on here. If I click on this one, it will drain whatever. In this case, I have hand soap. It will drain out, and you'll see little bits come by. And here's a little bit of a measurement. That's an L underneath there for liters. But you can also add some water. And if you add some water, you'll see the volume going up. And the pH is changing, but we can drip out here. Again, if we have this too high, it's right there. If I were to drain this out, now the pH meter is not there. So make sure you drag the pH meter into this. And if you want to start over, I don't want to do, let's try some chicken soup instead. You can go ahead and drag this into the chicken soup, and you can measure the pH, and you can add some water and play around with it. Okay, so please play around with the simulation and work on the Google Doc for you. Join me for Zoom office hours this week. Email me if you have any questions, but let's do some learning on acids and bases. All right. Have a great day.